I've heard a lot of the question of what would you rather terraform, Venus or Mars? So I how do I want to? There's so many different ways you can approach this. Let me go over what I think makes each one a good candidate. Just the good things. Okay, Venus,
Mm.
basically the same mass as Earth, right? So like our biology fundamentally would not have to change in response to the like physical forces there or whatever. Whereas Mars has only about a third or it's about half or a third of the gravity that we have here on Earth. So that could literally cause, developing humans to have like curved bones because your bone strength from the lack of gravity would not keep up with your muscle strength necessarily. So it could severely like warp your skeleton. It could be really bad. So like in that respect, Venus probably has an upper hand. Um, do I even know enough about this to make other arguments? I'm really struggling to find other positives for Venus. Actually, that's the real problem. What else is good about Venus? In terms of its elemental composition, I have no idea. Venus is covered in volcanic flows, so like the regolith on Venus may be much better for we'd have to obviously do some sort of agriculture or whatever. So that would be good. Um, Mars. So I don't actually. It's been a long time since I've heard a lot about this, but I actually fell asleep last night watching Star Talk, and they were
Yeah.
talking about Mars actually, and they were talking about the regolith on Mars because it's got a lot of perchlorates. I think they're called. Is that right?
It sounds right. I can't remember.
And from what I thought, I remembered those compounds like are extremely hostile to life. They would basically make the ability to put bacteria in the soil basically impossible. So I'm not. That's what I remember, and maybe that's not true. But I really thought that that was one of the huge problems. So Venus is like the crust may be much better. Um, After
But
that, I have absolutely no clue what the benefits of Venus would be because um, it rotates so incredibly slowly. Whereas on Mars, or
mm,
no, I said I was going to do the benefits of both. So the Martian day is incredibly similar to ours. So that's nice. I don't know if that's the most important thing, but if we're going to be transporting life forms from here to there, that probably helps quite a bit. You know,
yeah, I'd probably keep
there's
the same cycles.
the circadian. Sorry, say it again.
Yeah.
Okay,
Yeah.
right. Um, the or I guess another benefit for Venus is, although this will come up when we talk about how hot it is closer to the sun, and so therefore, there's a lot more energy for like photosynthesis, and it would be, like warmer. If you can figure out a way to make the temperatures not instant death, then you have pretty decent
A
conditions, I
giant
guess.
vacuum that you could just put all the gas out into space.
Yeah, that would be nice. Well, you can't have an atmosphere next to a vacuum, so eventually the vacuum
Oh,
of
fair
outer
enough.
space is just going to pull the Venusian atmosphere out of there, and we can start over,
Oh,
right?
oh darn.
Um, Jupiter's moons wouldn't be so bad to terraform. Yeah, problem with that is Jupiter has Van Allen belts that are so enormous and so radioactive that it's not really an option to live there.
But wouldn't technically like still living in the clouds of Venus still be terraforming of some sort?
I mean, I suppose, but that's just way beyond my imagination.
Yeah.
Which is not, that should never be the thing that makes, like, good science happens when people think of an idea that nobody else had. And technological advancements happen when somebody does the same thing. Like, if you ask people 150 years ago, what will the future be like? They're like, oh, well, everybody will have their own personal blimp. Because they literally couldn't imagine that a car would ever happen. So, I
Right.
mean, there you go. Anyways, Mars, there's definitely tons of water on Mars, way more than
Yeah.
enough. So that's excellent. Um, Other big benefits of Mars. Oh, well, the another good thing about Mars is it's easier to get to Mars because in order to reach something that's closer to the sun, what you have to do is when you fly there, you have to cancel out Earth's momentum around the sun. Uh, for Venus, that's not that bad because Venus is also going around the sun, but you do have to cancel out a huge amount of your velocity to land there. Funny enough, like the hardest place for us to go is the sun because you have to basically cancel
Interesting.
out all of your lateral momentum or whatever. So it'd be very difficult to get things to Venus. Much easier to get things to Mars, and much easier to get things off of Mars. It takes far less energy to leave Mars because there's going to have to be back and forth, right? I don't know if Mars's proximity to the asteroid belt could be considered like a benefit for resources. I mean, if we have the technology to start terraforming another planet, then the idea that we could asteroid mine, I guess, isn't too far fetched for me. So that kind of seems like it could be a potential benefit. So there we go.
Yeah.
Drawbacks: Venus. The amount of energy it would take to speed that planet's rotation up, which I view as a necessity, is literally unthinkable. Because here's like, not that it can't
Is
be
it
done.
even
I'm not
physically
saying that,
possible?
but it's such a bad problem that it takes you to the point where there literally is no point in doing it. It seems like, because what I mean by that is I fall back to the Neil deGrasse Tyson. Uh, uh, when people ask him this question, he says, "You're you're asking completely the wrong thing, or it's actually pointless because whatever it would take to terraform Venus or Mars, just do that to Earth. It would be quadrillions of times easier. Like
Yeah,
I'm not
exactly.
exaggerating in terms of how much energy it would take and how much it would cost. At least trillions of times easier. So
Yeah.
that's sort of now. I'm being good faith and I'm just comparing Venus to Mars.
Yeah, like
Whatever it
that
would take
obviously like our
to get Venus to start speeding up again would be so many orders of magnitude harder than the complete project of terraforming Mars that it just seems in my head, in my intuition, to be not even worth thinking about. So tell me what you've heard or what you think about that.
you'd have to repeat the question. Sorry, my girlfriend was just talking to me.
The most significant problem with Venus is not the temperature, I don't think. It's that we'd have to speed that planet's rotation up because it takes 244 days for that planet to spin one time.
Right.
Now, if we cover the entire planet in domes and we have artificial light, does that fix it? I guess it fixes it. But if that is something that is required, it's hard for me. What my intuition tells me is that getting Venus to speed up to a decent rotational speed, the amount of energy that would require would be several orders of magnitude greater than what it would take, the total energy it would take to completely terraform Mars. Not just to do one thing, but the complete terraforming of it, making it completely ready.
Right.
That's what I think, anyways. Because you're
Mhm.
talking about spinning a fucking planet up faster.
Yeah, the amount of energy you'd have to put in, I think you'd just have to like either take asteroids and just throw it at the planet for like literally like a century just to speed it up.
Yeah. Yeah. Now that I say that, I have just realized that, but Peterson, think about this. Mars has no atmosphere. Now, Venus, we have to fix Venus's atmosphere, but the Martian atmosphere basically doesn't exist, and we can't do anything about that because how are we going to give Mars a magnetic field? That, now that I think about it, in terms of how impossible would that be, giving Mars a magnetic field sounds like that might actually be more difficult than speeding up Venus. I don't know how we would do either of them, but but giving Mars a magnetic, I mean, you'd have to build a machine that does it. So I have I
It's
I don't know how
that
you
or
would do
you,
that either. So what that does then is I think that cancels some things out because Mars is going to require living in domes of some type. Like we're not going to be able to live outside on Mars. I don't think. Without a
no.
magnetic field, I don't think that's possible. Uh, so if that's the case, well, then the fact that we can't speed up Venus and we'd have to live in domes there, well, you know what? Maybe that cancels them out. So we're that we're even. I don't know
Yeah.
what I was trying to say, but I think maybe we're even on those 2 points. So the rotation of Venus is canceled out by the non-magnetic field of Mars.
Fair enough. So then,
Interesting.
second part of the question, if we were to, let's say, like on both ends, we were unable to create a magnetic field for Mars and we were unable to speed up Venus. Let's say,
Oh
like, we're
wait,
like, no,
shit!
this
But
is just
Venus
way
doesn't spin. Venus doesn't have a magnetic. Well, I mean, it wouldn't matter because there's yeah. Does Venus have a mag? No, it does.
I think it has a pretty strong magnetic
Strength.
field because the core still is molten and
Yeah. Well, but
still
it
spinning.
barely spins. Yeah, I have no idea how strong Venus's magnetic field is.
It's got to be fairly strong enough if the atmosphere is so thick.
Yeah, yeah, because that's what protects it from the solar wind. But I have no idea how strong its magnetic field is compared to ours. It's very weak. I mean, I would assume it is, but go ahead and whatever you were talking about. Sorry.
But I was gonna say, like, let's say, the scientists come up and say, like, this is just theoretically basically impossible. Like, you would just need so much energy, it's just not worth doing. If you had to choose on whether living on a blimp on Venus versus domes in Mars, which one would you rather choose?
Domes.
Domes?
Yeah, I mean, because doing that on Venus, it wouldn't be the same as being in the International Space Station. You'd still have weight to you, I guess. Um,
You should
but
still be able to feel the majority of the gravity.
yeah, yeah, you would. So I guess there's that. But I still think actually living on the ground. I mean, it's just more practical and safer by again orders of magnitude. Somebody said it's 0.0015% of Earth's. Okay, that makes sense. But I mean, Mars doesn't have one either, so I guess that point doesn't really matter. But yeah,
Yeah,
I think Mars is more practical and safer and cheaper and easier to scale up. I mean, how the hell are you going to
right.
scale up blimp civilization? Like that would be so freaking.
I don't know. I
That'd
think
be
it would
so
just be cool.
incredibly difficult.
I think it would be pretty cool just having like bridges between
Oh, it would be
blimps.
cool,
It would be so sci-fi.
but very impractical, I guess.
It absolutely impractical. Could you
Yeah,
imagine like a storm that rolls in with a freaking blimp?
yeah,
What would you
um,
do?
yeah. That kind of seems to be the big issue because, like, for Venus, we'd have to. How much energy would it take to be able to live on the Venusian surface without fundamentally changing its atmosphere and its temperatures? That just seems too incredible to be practical. So I feel like you're stuck with trying to live in its atmosphere. There's there's just simply no freaking way that that's easier, more practical, safer, cheaper, or smarter than living on the surface of Mars. Even with the challenges that Mars presents. We would have to heat Mars, but
Yep.
like you could do these calculations. Heating Mars to a livable temperature, I'm certain would be easier than cooling Venus to a livable temperature. Although if you're in the clouds, I guess there's a technically you could be at temperatures that fall within a pretty good range, I guess. But
I think I read something that the top of the clouds of like Venus is almost. I think it's just slightly colder than like Earth's surface, if I remember right reading.
well, I mean, the surface is 900 Fahrenheit, and space is whatever very cold it is. So there are temperatures somewhere in there that that are decent. Now it's going to depend on like where at what point in the atmosphere can you actually be neutrally buoyant. So I'm sure there's
And
some
not deal
maths
with the acid
behind that
rain
where you can
either.
figure out, well, yeah, but we can only actually be in this zone. And I don't know what those numbers are off the top of
Yeah.
my head, but
Yeah. I just think it's a really cool conversation because there's a girl on TikTok too that's just like super advocating that, oh no, we just need to go to Venus, not as much as to Mars.
yeah, I mean, well, like another thing is like, wouldn't terraforming the moon be a better option than either of those two? Like, forget the cop out answer of let's just terraform Earth and make Earth more livable. There's enough resources in space here to do that. We don't need a planet B, but why not the moon? I mean, the moon is a lot smaller than Mars, and I mean there would be, health issues with living in somewhere where there's very low gravity or whatever. But I mean, because of the proximity of the moon, it would be millions of times cheaper to terraform it. I would presume. So I don't know.
Mhm.
Nobody ever talks about the moon. What the heck?
I think because because I remember like back in when I was going to school, one of the topics was to try to like terraform the moon into kind of like a space gas station to where like you could just, I think you've heard of it too, where if you just flew rockets to the moon and then you just fill it up with more rocket fuel, you'd be able to go out to space further because you'd have less energy to spend to getting out of the atmosphere of Earth.
Yeah, it's good. Yeah, I mean that's kind of the whole point of why we're going back to it.
Yeah. And I think the reason why we haven't really talked about it for so long was because it was just so unreasonably expensive. But now that we're looking at going to other planets more often and doing studies at like Europa and stuff like that, or even Titan, we're looking at terraforming the moon into like some kind of space gas station so that way it's easier for us to travel there and travel back is what I'm assuming.
Yeah, yeah. I think that's kind of the point of like the one of the points for like doing the Artemis missions or whatever. I got distracted because somebody in the comment section said moon tsunamis would be insane. Um, I mean, there aren't. I mean, it would actually be the moon tides, and I suppose you could calculate this. The tides on if we put an ocean on the moon, the tides would be really extreme. But I mean, you couldn't put that much water on the moon because it doesn't have a magnetic field either, and it doesn't really have continents. There actually are huge differences between the highs and lows on the moon, but I don't think even if we put a lot of water on the moon, I don't think you would really get an ocean. You'd get millions of weird shaped lakes and then like crater lakes, and that's about it.
Doesn't the moon have a decent amount of water on it?
I mean, water does exist there. I don't think we really have a very good idea of how much though.
Okay. Because I remember like that was one of the big discoveries back in like 2016. I want to say is when they found water on ice, like water on the moon. Sorry.
I don't remember when it was, but yeah, we find ice there.
Yeah, and I don't remember how much it was that they discovered, but I don't know how much is on the moon itself.
No, me neither. I mean, I don't know how much it takes, but like this is an interesting question. If Lake Superior was the only fresh water available, how long would it last for humanity? You like I want to say this is one of those things where it's like the answer is either it would only last a few decades or it would last millions of years. Like I'm certain it's one extremely small number or one preposterously huge number. You know?
I would think it would be small because like you're still looking at a growing population, so you'd have to take that into account. If the
Yeah,
population was to stay the
but
same, then I would think
but
the
maybe we have
number would be
no
larger.
ability to wrap our heads around how much water is in Lake Superior. Is the other thing. It's like, yeah, I,
Oh
I
God,
don't
no!
know.
It'd be like however millions tons of cubic water or something like that. Just insane.
Yeah. The biggest
One
question is,
more.
would whalers on the moon carry a harpoon? They would, but there wouldn't be any whales, so they would tell tall tales and sing a whaley tune. That's what would end up happening.
One more question. In your opinion, where do you think is the best possible place for life in our solar system outside of Earth? Because that's the other big conversation people have had, where it's like, oh, we believe there might be life here, life here.
If the deal with Europa is we actually don't know how much liquid water it has. If it has, a decent quantity of liquid water, I would say that. I would put Enceladus in second place. People talk about Titan. I don't know. Like, we know it has permanent liquid, but it's methane. That just doesn't seem to me all that conducive for life, but, what do I know about extraterrestrial life? Um, so I would say Europa 1, Enceladus 2, and then, I don't know. Terms of that, I don't think I've heard that Ganymede might have liquid water under its surface too, and that would be fascinating. That would be pretty cool. What's the other than Io? What's the Callisto? I don't
Yeah.
know if anybody thinks there's liquid. Actually, Ganymede has a magnetic field. It's the only moon that does, so that's pretty interesting. Um, but I've never heard anybody say anything about if they think there's any liquid water there. So
I I heard of like somebody like as a scientist, and I remember I can't remember who was talking about it, but I remember it being like some kind of debate or whatever. And he said, I wish I could tell you the name of him, but he said that if we found extraterrestrial life that wasn't carbon based, we wouldn't even recognize it as life because it would be just so out of our comprehension to understand that it was a life or not.
I mean, I don't know about that because if it's life, it would presumably have some sort of. I mean, I was gonna say free range of motion, but I guess plankton really doesn't, and neither do trees or well any plant really. But um, I don't know. I mean, if it's alive, it would have to replicate and take in resources from the environment in some way. I would think, and I feel like that, like from a distance, if you just did flyovers of a planet, then I mean there could be endless quantities of microbial life and goo in its waters, perhaps that would be completely unknowable by
Mm.
just doing like a flyover or whatever. But if we actually saw it and it wasn't carbon based, I mean, it's hard for me to imagine what it would look like, but like characteristically, I just feel like something that would be living wouldn't just sit there and be unrecognizable or like indiscernible from random matter.
Right. Somebody brought up a pretty good question. Would it still fit our definition of life? That is a fairly good question because technically, like a virus is some sort of organism, but we don't consider it alive.
Yeah, because it doesn't have its own metabolism.
Right.
Um, I mean, I don't know. I mean, the definition of life is what life on this planet does. So how do I say this without sounding stupid? Like I was gonna say, it could be alive, but not alive. Like it's
Yeah,
so hard to think of like what to
it's
say.
such a it's such a broad answer, but it's so specific that
Yeah,
there's
I
not
mean,
really a way to describe it.
if if somehow some sort of system, like we have viruses here on Earth now, they require living cells to actually uh, make additional copies of themselves. If we could somehow find a planet that has some sort of virus-like replicators, um, but there isn't any life to do it. They rely on it happening in a different way. Then I think we would call that life. I guess it's very weird. You'd have to. I guess there are. I mean, there are astrobiologists out there. I don't know any personally, but they've been on Sean Carroll's show podcast before. So yeah, that would be
Hmm.
like what if it doesn't replicate it itself? How could something be considered life if it doesn't do that? That's a
Mhm.
interesting question. So
And it would be weird if that the sense of us being a carbon-based life form would be the outlier in terms of internet or like astrobiology. If carbon was the outlier, and let's say, I don't know, we'll say like what's another form of what's like silicon would be the closest one would be the next.
it's in the periodic table, or it's
Yeah.
under carbon in the periodic table, so it has the same sort of chemical properties.
Yeah.
I don't know. Like Richard Dawkins has he lays out the logic for it very well, which I'm not going to be able to replicate because I just haven't spent a lot of time with the argument. But if you read The Blind Watchmaker, which I'm like in the middle of The Blind Watchmaker right now, he talks about that if we find life on any other planet, it's going to operate according to Darwinian natural selection because it's so elegant and works so well
Mhm.
that that doesn't mean that it literally has DNA or anything like that, or that the life forms would look like what we have here on Earth. It's just that it would be Darwinian in that sense. And the thing with like carbon and silicon, that's I don't know. Like if you look at a really great book on I think it's called The Disappearing Spoon. I know it's by that author. He talks about carbon versus silica based life. He's like, yeah, I mean, people argue that maybe silica based life is a thing, but carbon is extremely common in the universe.
Mm.
And there's well, silicon is actually more common in the universe than carbon. Well, let me take that back. I'm not sure if that's true, but it's definitely more common like on the surface of Earth. And it's like not even close. But what you find is as you get more complexity, carbon starts to vastly overtake silicon. I don't have the numbers, but the ratios are in there. Like silicon is almost half of Earth's crust. So in soil, the silicon to carbon ratio is like thousands to one. But then, like for incredibly simple forms of life, like algae or diatoms or bacteria or whatever, carbon is more common, but it's the ratio is not preposterous. But once you get to like plants or then like a human, it's tens of thousands to one in favor of carbon. It starts going the other way. So it just kind of seems inevitable that silicon is actually just not great for complex life, or even simple life, really, because if it were, then life on this planet probably would have exploited that. Now, it could get out competed because of dumb luck at the same time, I guess, but really seems like it would probably be carbon based.
Well, you just destroyed my childhood dream of having a transformer.
Well, those are metal, not silicon.
I think they were silicon-based life. I think they're
That's an
considered
interesting
that.
question. I mean, if they're like robots, then I guess like fundamentally they are, but in a way.